Okay, Bismillah Rahman Rahim. So welcome to this, I think it's the 6th lecture today on big data wrangling. And what we have to cover is an important topic in statistics, which is called statistical hypothesis testing. And in this topic, we are dealing with a specific case of analysis. Because in data wrangling, our purpose is to simply get to know as much as possible about the data. So there is a very strong difference between how the people behave when they analyze the data. So let me ask you, do you know what is a difference between what is the difference between a data analyst and a data scientist? Hey.
Data scientist, sir, is more towards machine learning, and that's on the other hand, the analyst is more towards data cleaning and those sort of stuff.
Yeah, you have laid the foundation, but that's not the whole answer. Data analyst is responsible for basically for analyzing the data with respect to capturing the data, with respect to cleaning or wrangling the data specifically, with respect to doing the exploratory data analysis to understand more and more things about the data. And our topic today is regarding that, and also with respect to reporting. Okay, so data analyst has also got to do with the business intelligence, along with all the other activities that I've told you. And he will also profile the data. He will also do data profiling. For example, data profiling means you can say building a profile of each column. Okay, that's what I've been telling you, that when I told you about the midterm in the last week, when I was very sick. So I told you to profile each column. I did not use this word profiling, but that's what you call it, that when you analyze each column separately, then that's called profiling. So I want to build a profile of my data. So for that, you can build a profile like this. Okay, I have column 1 and blah, blah, blah information here. Okay, this is the information given by column 1. Column 2, this blah, blah, blah. This is the profile of column 2. So that's how you work. That's how you're supposed to build a profile of your data. And when you do the project of this course, then obviously you will be required to build a profile so that anyone can understand each column of your data. Is this thing clear? Yeah. Is it clear? You can please converse during the course. During the lecture, you should do conversation.
That's clear.
So profiling, you can say gathering the data. Okay, then obviously storing the data in some database. Then if you want to integrate the data, if you have data from different sources, you want to put them in one database, then you have to do data integration. Then obviously you have to do cleaning, and you can also call it wrangling. And then you have to do EDA, which is also part of wrangling. EDA stands for exploratory data analysis, in which you do things like clustering, hypothesis testing. Okay, you make some charts to understand the data. So I think charting you already know for building the profile. Hypothesis testing, inshallah, we will finish today. And clustering we will do in the next class, which is extremely important, clustering and also regression, although that is also part of machine learning. So, and then obviously the security of the data is also part of the data analyst. The data analyst is also responsible somewhat for the security, and then reporting and dashboarding. So when you see a JD for a data analyst, then this is what is expected of you. That's a lot of stuff that you need to take care of, and obviously this includes the interaction with the business. So you need to be able to interact with the data scientist. On the other hand, like I told you before, the data scientist, किसी ने सही कहा था, deals more with machine learning, which we also call data science. That's mean predictive modeling, time series forecasting, that sort of stuff. Is this thing clear? So the data scientist is not, the data scientist might say he might say okay, I'm not gonna do any SQL. Okay, SQL, all the things regarding SQL is part of the data analyst. But if a company does not have a data analyst, they just have hired a data scientist, though they expect him to do everything, which the data analyst does as well as the data scientist does. So there is a distinction. So you should be able to understand this distinction. Okay, is this thing clear? Gee, is this thing clear?
Yes, sir. It means that data scientist is also a data analyst.
No. Data scientist is not a data analyst, because when you talk of machine learning, then you have to do some things which the data analyst will not typically do. For example, in machine learning, you have things like data transformation. You have data cleaning. Now you will say, why data cleaning? Because data cleaning is the part of data analyst. The point is, when you do machine learning, then your cleaning activities are also different. So a data scientist will need to do some sort of cleaning, even if the data is already cleaned. You understand? The data scientist might say, no, I want to clean the data according to my own requirements. So there could be he might want to do it, or she might want to do it on his own or on her own. So they might not agree on a general cleaning strategy. So therefore, it is better to write it like this here. And then we have something here which is called, you can say, data transformation, data cleaning. Then we have feature selection. Then we have algorithm selection. Then we have parameter tuning. So there are a number of activities which the data scientist has to focus on. So with regards to and then obviously when the model is made, then they have to deploy the model and tune it from time to time. Tuners, I think I can use the updated regularly. You understand? Okay. So in this way, the job of a data scientist becomes different from the job of a data analyst. Both the jobs are pretty intense. They are pretty aggressive, and the person is expected to do a lot of work in order to fulfill his JD. There is no piece of cake in any of these job descriptions. Any questions?
No, sir.
Okay, so you can, as an exercise, you can see let's see some job. I will just show you so that you can get a So let's see some ladies here. Data analyst job description. Okay. What does a data analyst do? Responsibility, skills. Look, data analysts gather information from various sources. For that, they need to be expert in SQL and also Python programming, and interpret patterns and trends through EDA and basically through BI tools. So as such, a data analyst job description should highlight the analytical nature of the role. These are the collecting and interpreting data, okay, analyzing the results, reporting the results, identifying patterns and trends. That is done through data wrangling activities. Like you can do that through the charts that you have made up to now, the normal distribution plots that you have made up to now, that they identify the patterns and trends. And then this is for the business requirement, working alongside teams within the business or the management to establish business needs, defining new data collection and analysis processes. So this is something extra. So these are all the mathematics, computer science. So no mention of predictive analytics here. Similarly, you can have the same for the others situation as well. You can browse other. So I hope the distinction between data analyst and data scientist is clear, right?
Yes, sir.
Okay, so now, first of all, we have to discuss what do you mean by exploratory data analysis. So what we are envisioning is that basically data is like water, large repository of water. Okay, so data is like a large repository of water. So what we have to do with this water that we need to control it. We need to clean it, control it, and then use it. Okay, so when you have so much data that's like a large repository of water, so obviously first of all we have to process it. For example, जब आपके घरों में पानी आता है आप उसको filter करते हैं, right? And then you drink it. So similarly, we have to process the data. So in the process of the data, we do two things. So in processing the data, we are primarily doing two things. First of all, we have to clean it. So what does what does cleaning mean? Can anyone tell me the activities in the cleaning process? G, what are the typical activities in the cleaning process?
Eliminating null values, one of the elements.
Missing values, and what else?
So removing unnecessary rows, columns.
Outlier detection and dealing with them. What else?
Correction of data. Fixing the dirty data.
Correction of dirty data, or no, correction of incomplete or incorrect data. और उसके अलावा
Sorting also.
yes, sorting data is also good. You can say removal of unnecessary data which we don't need for the analysis. Okay, so and there are other activities as well which you guys have not mentioned, but they are there. Okay, So that is called processing. Mein first thing is cleaning. Okay. Processing mein what's the other thing? Understand the data. Now you might ask me, for understanding the data, I have business intelligence tools, I have data science, predictive modeling. So why do I need to understand that at this stage? I have BI tools. Why do I need to make the understanding in Python, right? Like you have been doing in your midterm and before, you are generating charts to understand each column, to profile each column. Why now? So what's the answer to that? Shabash.
To understand the procedure for analysis purpose.
Yeah, to some extent, yes. You need to
transformation.
G.
Transformation
Transformation is not the answer. Transformation is primarily done for data science activities, or for some other reporting activities. You can transform the data. मेरा सवाल ये है कि when you have a BI tool to understand so much about the data, then why we are insisting to draw the patterns and draw the charts in Python notebooks?
So to analyze the trend, maybe.
Yeah, look, there is something which is called doing things before doing them. Okay, you can get something done later on, but you want to have a head start, right? The point is that you need to develop your own understanding of the data on a column by column basis. Okay, right now I'm talking about single columns, like you generate the normal distribution plots, yeah, string values ke liye you generate the frequency graph. Okay, that's pretty easy, but that develops an understanding. We also have to do correlation analysis, in which you can compare two columns together, how they are correlated. So we have to also see that. That is also part of the same game, understanding the data. Okay, so the main point is I need to develop my own confidence and knowledge about the data, and also get to know the profile of the data before I give the data to some BI tool or some data scientist. You understand this point? I have been stressing all along that you need to have good knowledge of the business, and you need to have good knowledge of the data. If you want to work at a managerial position, then that is what you need to have. Otherwise, you are just a fresh graduate who is able to do a few things. That's it. Unless you develop the knowledge of the business and the knowledge of the data that is in your hands, you cannot you cannot manage any analytics project. That's my mantra, you can say, or that's my experience. I'm talking from my experience. So therefore, I give a lot of stress to EDA activities. So for understanding the data, we have we label these activities as EDA, exploratory data analysis. Okay, and I gave in the last slide or in the last view of this Zoom whiteboard or whatever. So I gave you this some activities of EDA. So EDA may, what you want to do is to build profiles of single column. Yeah, you can call it univariate, and build bivariate profiles, yani 2-column bivariate profiles. So in this case, you can do correlation or covariance analysis. Yeah, we'll do this in the inshallah ta'ala next class, okay? Or univariate, what do you do in the univariate case for to build profile of a single column? Hurry up, please.
We built histogram, like you described
Yeah,
the
histogram,
category.
normal distribution plot, frequency graph, or for a string value. So build bivariate profiles, and then in the third case, it's more complicated. You can do cluster analysis, which we will do inshallah next time, next class mein. And we can also do hypothesis testing, which we will do today inshallah. I'm just laying the foundation. Cluster analysis, hypothesis testing, single column profiles, cluster analysis. What else? एक और चीज थी जो मैंने बताई थी. What was there? What was the last? There was one more thing.
Modeling the data.
Sorry,
To build
no.
a model.
Data modeling is more of a data analyst role. It is not. Yeah, data modeling comes in data transformation. When I change the schema of the, you know, the schema that is given to me, the tables that are given to me, I'm not comfortable with that. I need to develop my own database. So that's called data modeling. So that can come within data transformation, not within the wrangling part. Wrangling, I'm trying to understand the data which is given to me. I can model it later on according to my own requirements. You can say regression, or, you know, just scatter plots or line fitting, to understand the trend, which is also related with this bivariate profile when you develop the correlation analysis. So these are some of the activities. There might be more. I'm sure I'm not up to date with this, but I think these are some of the basic activities we need to build the profile of your data. अब आप situation को understand करें कि let's assume कि you have built up a profile of your data. Now comes a data scientist. Okay, so he can save a lot of time by just reading the profile of your data, and he will understand what the data is all about. He will understand everything about hypothesis testing, regression, etc. So he will know कि अच्छा हाँ यार ये सीखा, I don't need to start from the scratch. If we don't build a profile of the data, which the IT team will never do it, because it's not their job to build a profile of the data for analysis, because there's typically no data governance. And even if there is data governance, data profiling might not be the top priority. So, so therefore, it is always better to build a profile of your data, so that all your data analysts which you are going to hire, they will just go through the profile, they will get a knowledge, or you can just give them a presentation of like 15 minutes. You can walk them through the profile, because they are already data scientists or data analysts, so they will understand things very easily. They are supposed to. Otherwise, you should not hire them if they don't understand your profile. So they will understand it, and then they will be able to make a head start, inshallah, and start working. Is this thing clear? Are any queries about this right now?
Okay.
Okay, so you start thinking about these things from in your own companies. We have people from State Bank, we have people from other companies. जो भी मैं आपसे बात कर रहा हूँ, you have to map it to your own company. You don't have to take it like a diploma में भी ये बात बताई जा रही है. You have to see how much it is applicable in your own company, and then it will be really useful to take the diploma. Otherwise, what's the use of doing the diploma if you are not able to map it to your own company or your own startups, whatever, or your own carriers? So it's better to, you know, do these things and standardize things in your own companies, and then also inform me so that I can put that on LinkedIn if you decide to change something in your company, you know, based on the knowledge that you get here, etc., etc. Okay. So I'm clearing the drawings. Okay. Okay. So now today we have to start with hypothesis testing. So hypothesis testing. Let's call it the statistical. Okay. Statistical hypothesis testing. So this is part of statistics. Up to now, the statistics that you have used, making the histogram and the normal plots, and you know, making the aggregate plots and all those things. That's called basically descriptive statistics, because you are describing the data. How many rows are there? What is the mean? What is the mode? If you do a dot info, data frame dot info function, then it will tell you many things like quartiles, upper quartile, lower quartile, box plot. All that is part of descriptive statistics, which can help you develop your understanding of the data. But there is also another part of statistics which is called inferential statistics. So in that respect, what is inference? What do you mean by inference?
To predict something based on the given data.
To do what?
Prediction.
No. No.
Conclude, maybe. Infer.
Sorry? Gee, Binish, what is inference?
So finding the probability based on
maximum deviation.
Finding the probability, no. Deviation, no.
To deduce.
Sir, based on hypothesis, कोई conclusion draw करना.
Conclusion draw kar lein, to some extent, but very far away still. Gee, Farah Mehboob, I think you were not there in the first class, right? With that I took on site.
Gee, sir, this is the first class I've joined.
Acha, you are the Farah from our faculty.
Yes, sir. Should I answer?
Are you the same Farah, right?
जी बिल्कुल sir, I'm the
अच्छा
same
ठीक है ठीक है, आपको तो इजाजत है, कोई मसला नहीं है. Nashid, what is inference?
So based on the evidence or facts, you got to a conclusion.
So you can say कि when I say कि infer, when I infer something, when I infer some knowledge, then I reason out or deduce some knowledge given some information. So basically inference means ke reasoning out some new knowledge from a previous knowledge. Okay, like we give a very very childish example ke all men are mortal. So Ahmad is a man, so Ahmad is mortal. So I reason out that Ahmad is mortal. That's called inference. Okay. But in the case of statistics, what it means is ke make some conclusion about the population from the data of the sample. And I think I have told you in the first classes, I think when we were working, when we started the course, there is the training data that you have, the databases that you have, they are actually a sample of the data. Yeah, I think I told you this one, right? Okay, the data that you, for example, you say, okay, I want to see the last 3 years of sales data. So that is just a sample, because the sales data is being generated maybe since the last 7 years or 8 years or 10 years. Okay, and maybe you just have data for 10,000 customers. Here you just have data for 10,000 customers, while in reality you might have 20,000 customers. Okay, so what the data scientist is able to see is always a sample. Okay, it's never the whole population. So the population is here, the data, you never have the data for the complete population. For example, if I want to make a claim that Pakistanis are typically very hot-tempered people. Okay, so I can't, I am making a claim about the whole population. So how do I make that claim? I make that claim because maybe I sample, let's say, I don't know, kitni आबादी है, तो I take a sample of, let's say, 1 lakh Pakistanis, 100,000 Pakistanis, okay? And I monitor their temper, what they do, how do they behave typically in different areas of the city, in their house, etc., etc. And from that, I make the conclusion that they are really hot-tempered people. Pakistanis are hot-tempered people. Okay, so they are थोड़ा सा बस बहाना चाहिए होता है और फिर वो गुस्से में आ जाते हैं. ठीक है, घर में हो या बाजार में हो. So I just had a sample of 100,000 people, which is also a very big sample, by the way. And then I make a conclusion about the whole population of Pakistanis. Pakistanis are hot-tempered people. So this is what we are basically doing in hypothesis testing and in statistics primarily. In statistics also, in descriptive statistics, what we're doing is that we are making a claim about the population. कि population में ऐसा होगा. Because we cannot make claims on the sample. A sample is just one sample. Tomorrow I can take another sample. Day after tomorrow I can take another sample. So that's not something which is reliable. But I want to be able to infer something about the population from the data given to me about the sample. So that's the thing that you need to keep in mind. So infer some useful knowledge about the population given the data about the sample, or given the sample, you can say, yeah, is this thing clear? Is this concept clear? And you are always given the sample. You are never given the population, but you want, whenever you make a claim, you have to make a claim about the population and not about the sample, because the sample is not reliable. Okay, this has to be crystal clear. So whenever you make a claim about the data, you make a claim about the whole population, because the sample is not, a sample is temporary. It is bound by time. Okay, I took a sample of the last 3 years. I took a, or ye bhi to, this is my own understanding, because typically it is not easy to get a sample of the last 3 years unless you have a very good relationship with the business. They might give you the sample just for the last 1 year if they want to test your skills on data science or data analysis. Why should they give you 3 years data or 5 years data of their own whole company? So these kind of things, they also need to have some sort of, need to have a good understanding or a good relationship with the business to get more and more data. That is also true. So a sample is nothing. So you need to have a very large sample to make a claim about the population. That's the first thing. So is this thing clear? Any queries here? So all all the statistics. What time is it? Yeah, just. सही है. So all the statistics is about that, right? You have to make a claim about the population based on the sample of the data that is given to you. So this is the reason that we want to update the model. We just try to understand what I'm trying to tell you here. Let me just clear all the drawings. So why should I update my BI charts and my predictive models and my analytical models or data warehouses? You know, the scenario that I'm talking about is that I did my BI or machine learning or data warehouse and I deployed it. Okay, is this thing clear? You did it and you deployed it. So now the question is, why should I update it? When should I update it? We'll take a namaz break because I'm sick, so I have the luxury to pray at home. आप लोगों की जमात में जिन्होंने पढ़नी पढ़ लें, just take a break later on. Is this problem clear? I did my this BI, ML or data warehouse, whatever. I built it and I deployed it. सही है? Is ये clear about? Do you understand the question here? जी. अरे भाई कहाँ चले गए सारे?
Yes, sir.
Yes, sir.
Do you understand the question? What is the question? क्या पूछा है मैंने?
Basically, you're asking कि the data जब collect कर रहे हैं उसके through ही आप update करेंगे ना models.
अच्छा चलें. I think ये नमाज break ले लें, ठीक है? Let's take a namaz break 10 minutes and then come back. When you have made some BI model or the data science model, then you need to update that. So why should I update it?
So because we are continuously getting a new data, and through new data we can somehow get a better understanding about the portion that we are going to analyze through the data.
Yes, because we are regularly getting new samples of the data, right? Every day is a new sample of the data. The probability distribution of the new data might change from time to time. These changes will disrupt our previous analyses. Is this point clear? When the new data is coming, for example, you got some new customers, but those new customers were not present when you were learning the machine learning model or when you were doing BI. So these new customers have a new pattern of buying or selling, right? So they are not reflected in your analysis. So you need to update your model to reflect the new customers from time to time. Is this thing clear?
Yes.
So the point is that if you now, this is where I want to stress the importance of the situation. Okay. If you do not make a claim about the population, you will always be working with samples which is random. समझ में आ रही बात की? So I have a population here and I have so many samples that I can take from this population. So there are thousands of samples I can take. So instead of talking of thousands of things, I just want to talk about one thing. Okay? So if I talk about one thing, then no matter how many samples I take, this thing remains consistent because I'm just talking about the population. So I don't care how many samples you take from it. I know what is happening in my population. So hypothesis testing is about making claims about the population. What can I claim about the population based on the data of the samples that has been given to me? I need to be able to do that. In this case, when I said I need to update that, so my assumption is that my population is changing because I'm getting new customers. So I need to relearn the model, update the model so that I learn the parameters of the new population. My population is changing because I am getting new customers. So definitely I need to update the model because my population is changing. Is this thing clear? This concept should be clear in your mind. Okay.
Yes, sir. Yes, sir. The concept is clear, but I have a question. The question is that how do we know that the claim that we are going to do about the population from the sample is reliable?
Yeah, that process is called inference. That is a good question. Basically, this is the inference that I'm doing. I talked about the inference, right? In the last slide, I talked about the inference. So I infer knowledge about the population. So the point is that in the previous several tens of years, or you can say 50 years or 100 years, some statistical techniques have been developed which are in use since a long time, and these statistical techniques are basically helping us make the inference about the population. So they have been tried and tested by many mathematicians and statisticians, and they are being used extensively throughout the world to make a claim about the population. So now they have become the de facto standard for doing this sort of stuff. So we are just using those techniques which have been developed several tens or hundreds of years ago, and they have been really pretty reliable. So the hypothesis testing that we do, the statistical tests that we use in hypothesis testing are exactly that. They are very reliable tests which help you make a claim about the population. Okay. Achha, in this case, so whenever we do hypothesis testing, we have a null hypothesis. Okay, null hypothesis is basically what you don't want to happen. Okay, and alternate hypothesis, what you want to happen. So in order to understand this very childish statement, what I mean to say, okay, what do you mean by happen? So what is happening? What is happening? Okay, happening ka kya matlab hai? So for example, I can say that mean of one column is different from the mean of the other column. That is one thing I would want to say. Okay? Or mean KPI is different across different product groups. For example, the mean sales or the mean turnover or the mean ROI is different across different groups of products. So these kind of things I would want to make a comparison in my data analysis. Okay. For example, I can say, is the average age of women different from the average age of men in a sample of, let's say, 10,000 people? Is there a significant difference? So the word that we use typically is is there a significant difference between the means of two columns or between multiple groups? Okay, so that's the word we use. Is there a significant difference? So I'll give you the example later on, but what you need to understand right now is that I have two things which are important. One is that you need to declare a null hypothesis. Null hypothesis could mean that the means of the two columns are the same. There is no difference. Okay. And the alternate hypothesis, you can claim it as that the means of the two columns are different from each other. Okay, so whenever you do a hypothesis testing, you always need to have a null hypothesis and an alternate hypothesis. And after that, what you need to do is that you want to disprove the null hypothesis. Obviously, that is not what I want. I want null hypothesis to prove it false. And you want to prove the alternate hypothesis. That is, you want to prove it true. Do you understand what I mean? So what you want, first you declare a null hypothesis and then you declare an alternate hypothesis. The null hypothesis you would want, aapki khwahish ye hai ki yaar wo false ho jaye, because then that means nothing for you. If there is no difference between the average age of men and women, then it just does not add anything to the analysis, right? Then that means that men and women are the same in the sample. They are not differing based on age. So you can't make any claim about about the population of men and women. You can't make any claim. So ideally what you want is that alternate hypothesis gets accepted or it turns out to be true, and the null hypothesis turns out to be false. That's what you want to happen. Okay. And the point is this, what you need to understand is that hypothesis testing helps you make a claim about the population. If the alternate hypothesis is true, then you can generally claim your result. Is this thing okay? Is it, you need to be clear on these concepts. Is this okay? We have been talking about the fact that why we need to make a claim about the population. You understand why that is important, right? I need to make a claim about the population because uske bagair mein, I can't talk about the validity of my data. I can't talk about the validity of my claims. Okay. How do I do that? I do that by statistical hypothesis testing, in which I have a null hypothesis and I have an alternate hypothesis. I want to prove the alternate, I want to disprove the null hypothesis. Is this thing clear up to now? Any questions? जी. Okay, so Binish is saying okay, so I assume that everyone is saying okay. There's one more chat. Clear. Nashitari is saying clear. Okay, so let me just where is the result? Okay, so how now the other question is, let me just so the point is ke, how do I ensure, how do I determine that the alternate has won or lost, or the null has lost or won, whatever. Okay, so how do I determine that? So very simply put, because we can't go into too many statistical details in this course, so what happens is that I calculate a parameter which is called a p-value, which is actually a probability of making probability of making an error about my claim. Okay, so I calculate a p-value, which you don't have to calculate that. What I do is that I run a statistical test based on my requirements. Okay, for example, if I have to say that the means of two columns are different from each other, then I have to run a t-test, or it is also called a student's t-test. So in that t-test, what will I do is that I will compute a statistic. In every hypothesis test, I will compute a test statistic, and then I will compute a p-value. Okay, and this p-value is going to let me know whether the alternate has won or the null hypothesis has won. If the p-value is less than 5%, then we basically say, okay, alternate hypothesis is true. This is what I want. And if the p-value is greater than 5%, then we reject the null alternate hypothesis and we say a null hypothesis is true. Sometimes we even take it as 10%. So if it is less than 10%, then alternate hypothesis is true. If the p-value is greater than 10%, then the alternate hypothesis is definitely false. And we can't take it more than that. So 10% is the limit. So p-value actually wo error hai ke how much error I can make in making the alternate hypothesis true. What is the chance of my making an error on my claim about the alternate hypothesis? If that is less than 5%, then I'm okay. I can say alternate is true. If the p-value is greater than 5%, then I say null hypothesis is true. Ideally, to ye scenario hota hai. But you can also assume 10% sometimes. Now, what happens is that this is a sort of a complicated story in which what we're using is that we are computing test statistic. We are computing something which is called a degree of freedom. We are selecting significance level. Of testing, which is typically 5%, which I told you. And we are using data from a probability distribution table to determine whether alternate is true or not. So ye basically char kam ho rahe hote hain, to I cannot go into the details of these things because it is going to confuse all of you guys. And it is information which you probably do not want right now, because it is a statistical sort of thing. What you need to understand right now is that you need to understand which test I have to select. Okay, that's what you need to understand first of all. कि आपने टेस्ट कौन सा जो है सिलेक्ट करना है. So let me just write this down here in a which test should I use. That is it. That is what you need to say. So you will be using two tests, t-test. By the way, the t-test has many different flavors: one-tail test, two-tail test, pair test, independent t-test. There are many versions of t-test, but you are just going to use the one जो कि normally Python के अंदर default behavior पे इस्तेमाल होता है कि to compare the means of two different columns. That's it. उसके अलावा you are not. I don't think so. You will be able to use that. T-test is rarely used. The other one which you are going to use is ANOVA, which is quite used quite frequently. So I'll just tell you the difference between these two. And there are other tests as well. Chi-square test, for example. There's also the chi-square test. There's a different test for normality. Okay. For example, for the normality, we have the Anderson test. But you just need to understand the things about the p-value. That is more important for you. If the p-value of the test is showing as less than 5%, just accept the alternate hypothesis and reject the null hypothesis. That is what you need to keep in mind. So I hope that this is clear. So let's move now to the next slide, which is yeah. So this is the t-test. So t-test scenario is pretty simple here. I took one of the scenarios. So in its most simplest form, t-test is used to determine whether the means of two columns are statistically are significantly different from each other or not. This kind of test finds its application in social sciences type of thing, or psychological testing, in which you have a group of patients, you give them a drug, and then you notice their behavior. Then you give them another drug and notice their behavior, and then you determine whether there is a statistical or a significant difference between the behavior or not. You cannot just compare two means together and say that they are different from each other. We have to determine the statistical difference at the pair level, pair t-test. So for example, this is a column of age of men, this is the age of women. So their average age is 39.3, here is 39.2. So हम कह सकते हैं कि यार their mean is almost the same. They have the same mean, but this claim will not be true unless it is verified by the t-test at a statistically significance level, because the t-test is going to work at each pair level. Okay, so it's going to work at each pair level, and then it is going to tell you something whether it is significant or not. So t-test has a whole distribution table. It has degrees of freedom. So there are it's a very it's a very comprehensive test as compared to just comparing the means directly. तो जब भी आपके पास एक ऐसा सिनेरियो हो कि आपने पहले कुछ काम किया हो, बाद में कुछ काम किया. For example, you have an e-commerce portal and you are showing products to user based on algorithm 1. So you select 500 people and see their response on algorithm 1. Okay. Then you change the algorithm and then you select those same 500 people and see their response on algorithm 2. And then you compare their response. So you cannot compare just the average response. You have to compare the response based on the t-test. The t-test will tell you whether there is a significant difference between the response or not. So in this case, the alternate hypothesis is yes, there is a difference. The null hypothesis is that there is no difference. That's it. So you run the t-test in Python, and if the p-value is less than 5%, then you can say the alternate is true and there is a significant difference, and that is the claim that you can make about the population of men and women. Otherwise, you cannot make any claim about the population. Okay. So if this thing is not clear, then you can listen to the video again, or you can ask me the question right now. सही है? Clear है? So here T is the test statistic which is computing for each t-test execution. M is the mean, mu is a sort of a threshold, S is the standard deviation of the column, and N is the number of observations. So in this case, I think I have 9 observations, and S is the standard deviation, mu is the threshold, M is the mean. And this is actually a generic formula. When I'm comparing 2 columns, then obviously this mean is going to be the difference between the mean, and this is going to be the difference between the standard deviations, which is computed on a pair by pair level. And the selection of mu is basically based on some criteria which I don't know right now, but that is how it is computed. So I compute the value of the test statistic. Beside that, I also compute a degree of freedom. So degree of freedom is typically the number of observations minus 1. So in this case, the degree of freedom will be 8. So I take this statistic, I take the degree of freedom, I select the significance level as, let's say, 5%, so 0.05. And then I use the table to determine whether alternate hypothesis is true or not. Okay, so let me just give you an example of that. So this is the table. So for example, let me just put it here. So let's assume I'm taking a one-tailed test. का मतलब ये होता है कि we are just talking about the one on one side of the distribution. So you can say greater than or equal to X. What is the probability that this is going to happen or this value is going to occur? In the two-tailed scenario, I have a range. So because I'm talking of both the sides of the tail of the distribution, so I'm talking of a range that less than minus x1, less than x1, and greater than x2, for example, something like that. So I gave a range. So typically we are dealing with the one-tailed scenario. So in the case of one-tailed scenario, the significance level I've chosen is 5%. So 5% is here. And the degree of freedom I have is 8. So in the 5% significance level is 1.860. So this is the value. So if my test statistic is giving me 1.860 or greater than that, then my alternate is true, because all these significance levels are greater than 5%, less than 5%. This here is greater than 5%, which I don't want. So my test statistic value has to be 1.86 or greater than that for the alternate to be true, because then the significance level will be 5% or less. If my t statistic value, uski jo test statistic value aati wo aati 1.2. 1.2 lies between here. So then that means that there is 10 to 15% chance of error in making a claim about the population, which is not acceptable at all to me. 10 to 15% chance of error is too high. So that is not acceptable to me. So in this case, that is, you don't need to see the table. You don't need to compute the degrees of freedom. What you need to do is that you just need to see whether the p-value of the test given by the Python function is less than 5% or not. If it is less than 5%, you immediately accept the alternate hypothesis. That is it. That is all you need to do. Okay, so that's the shortcut that you need. So I hope that this is clear. G.
Yes, sir.
So we'll do the example of the logins of the marketing data right now. Just hold up. Okay, so now we are in ANOVA. So in ANOVA, just wait, let me drink some water. क्या नेमत है यार पानी भी सीरियसली यार कोई जायका नहीं है और उसके बगैर गुजारा भी नहीं है. So ANOVA is basically analysis of variance. That's where it derives its name from. Analysis of variance. Okay. So in this case, what we are looking for is that we want to determine whether the KPI, which is obviously numerical, is significantly different across different groups, and that means a string value. So for example, I can say sales across products. Okay, I can say profit across customer groups. आपने customer groups बना दिए हैं, platinum वगैरह whatever, ठीक है. Profit across different customer groups. I can say the profit or the loss incurred across different aircraft types. So all of these things are use cases of ANOVA, and it's a very important statistical test to have. So first, so in this case, Haji, what will be the null hypothesis in this case? In the right side, you can see the example that I have sales across 3 different types of product categories, and their average value per group is 36, 37, and 38. On the face of it, you can say there is no difference between the mean sales per product group. Okay, there's 36, 37, 38 is just, there's no difference. I mean, this 3 values very close together. But I have to conduct an ANOVA test to make a claim about that. And again, the method is the same. ANOVA is a very complicated formula, but it's not outside the scope of our course. We compute like 5 to 6 different parameters in ANOVA before we can make a claim about the alternate hypothesis. ANOVA also has a table. It also has its own distribution, which is the F distribution. I also compute the F statistic. So whenever you compute ANOVA in Python, it will give you the F statistic. For the T test, it will give you the T statistic. So F statistic has a formula which is based on the variance of the sales across the different groups. So you compute the variance. That is why it is called analysis of variance. But that is outside the scope of this course. So what will be the null hypothesis? Shabash.
Nothing to the sales.
Null hypothesis क्या है? The mean sales is
Remain same.
Is the
Nothing
same
happening.
across clothes, toys, and carrots. And what is the alternate? The mean sales is different across clothes, toys, and carrots. Now, why is this important? Because when you're a sales manager or you are the line manager, you want to be able to understand which of my products sales are actually different from each other. For example, you can say the sales of Coke and Pepsi is very different from the sales of Coca-Cola milk. Okay, so you want to be able to understand or first of all, ANOVA will tell you there is a difference between the sales of Pepsi, Coca-Cola milk, Cadbury, ice cream, and let's say yogurt. Okay, so you'll say, "Acha, yaar, inki sales aapas mein vary kari." Now tell me exactly where is the difference? So the difference will be, the difference might be between toys or clothes. It could be between clothes or carrots, or it could be between carrots or toys. ANOVA is going to make a general statement कि यार इन ग्रुप्स के जो मीन्स है वो आपस में डिफरेंट है. अब डिफरेंस है कहाँ पे एग्जैक्टली, उसके लिए you need to run another test which is called the 2-key test. So ANOVA is only going to tell you that there is a difference between the means of the groups, between the mean KPI of the groups. 2-key test will tell you where the difference actually lies. Is this thing okay? So that's what you need to understand. So let's, I think we should go towards the hands-on. If you have any queries right now, then tell me. So just wait, I'll just let me. Okay, we were on to that wrangling thing, right? That in the last class. Can everybody see this?
Yes. Yes, sir.
Acha, just wait 1 minute. Right, so this is the test that we were looking at, the file that we were looking at last week when I was feeling really bad. So just let's execute these. So you can see here, okay, we have some, where is it? Yeah. So ये तब आप लोगों को, these are the 3 normal typical APIs जो के modules of Python. These SciPy is for the statistical analysis. Let me just, no, it's a bit better. Okay. SciPy is primarily an API for statistical analysis. Okay, so there was a time when people used to use R, and even now I think if you want to do statistical analysis, R is a better thing than Python because R is designed for statistical analysis. But लेकिन चूंकि Python एक development environment है, तो you can integrate Python with everything. So that's why Python is now the preferred, the language for even for statistical analysis. But if you want to use R, you can use R. So we have these tests like Shapiro. I've been talking about hypothesis testing. So we need to have a test. So we have the t-test, we have the ANOVA test, we have the chi-square test, which is used to find out the difference between 2 string values, whether there is a significant difference between the values of 2 string variables. That comes under the domain of a chi-square test. So that might come in your final exam. Normality test, Shapiro, Wilkinson also I think is a normality test. You want to test your data for normality. Similarly here, Anderson is also the same. Chi-2 contingency, I think, इसमें तो chi-2 is the chi-square test, and chi-2 contingency I think gives you the contingency metrics for the chi-square test. SM is obviously, ये तो हमने खुद नाम रखा है उसका ताकि हम उसको इस्तेमाल कर सकें. OLS is ordinary least squares. This is used in ANOVA. 2-key, I think जो मैंने आपको बताया था ये वो वाला test. QQ plot. What's a QQ plot? Anybody knows what's a QQ plot?
So it tells the type of
A type of
distribution.
No. A QQ plot is actually a quantile plot. So you want to test whether your data deviates from a normal distribution or not. So I forget exactly how it is plotted, but if your plot is coming exactly on this line y equals to x, then that means your data is normally distributed. Otherwise, if it is deviating like this or this, then that means there are probably some outliers. So you will have to use these things to understand them more properly. QQ plot, it's based on quantiles. You know, quantiles, you probably know about quantiles, like in the box plot case. So you have this box plot. So you have the quantiles, right? So this is the lower quartile. This is the okay, quantile is the percentile thing, right? This is the lower quartile, this upper quartile, this is the 50th percentile. So we talk about the 25%, 50% and 75%. So in this case of quantile plot, you are talking about all the numbers here. 1 to 25, 25 to 50, 50 to 75, 75 to 100. And based on that, you make this plot. So I'm forgetting the exact the method right now. Maybe I will tell you next time. Just send me a reminder. I don't have my notebook with me right now. I'll tell you how this is drawn. This is pretty interesting because this is also used in this kind of thing is very important for statistical testing and one other application which I'm forgetting. So quantile plots are important. Okay. In any case, we'll see how we have seen it. So let's okay, execute this. So acha, okay, so I did not execute this. Sorry about that. So I read this campaign head. So we saw this data last time. You wrangled it pretty good. I'm hopeful about that. I'll just mark the midterm on that. So so it's a pretty simple data. Now जो मैं आपसे बात कर रहा था कि यार डेटा क्लीनिंग, चलो क्लीनिंग, अंडरस्टैंडेबल, मिसिंग वैल्यू एनालिसिस, एरर्स, नॉइज, एक्सेट्रा, आउटलायर सब रिमूव कर. What about the data understanding or the EDA? So the EDA, if you talk about hypothesis testing, so you can immediately determine here. Okay, you tell me which two columns are likely to get a t-test in this data. Hey.
Age and gender.
I'm talking about a t-test.
The logins with login for weeks cells with the cells for weeks and login 6 months with the cells 6 months.
The t-test is conducted between same types. I can't make a t-test between login and sales.
And we can make the login for week with the login 6 months.
So what is the null hypothesis in this case?
The login for week and login 6 months will remain the same.
The null hypothesis is that the mean number of logins in 4 weeks is the same as the mean number of logins in 6 months. And the alternate is there's a difference between the mean of these two columns. Okay. So first let's check the missing values. So the missing values are not there. The types, do you want to convert any of these? Is everything okay here, or you want to convert some type?
Everything is okay.
आवाज कम आ रही है.
Everything is okay, sir.
Everything is okay. ठीक है. So now we do this t-test. So I conduct this stats.t-test end. What is end? India.
integers,
independent. ठीक है, independent t-test. Independent means I assume के one column does not influence the other column. I am recording the observations independently. So typically that's the typical test that we do. So I just conduct the test. कहाँ गया यार इसका? Stats is not defined. Let me just check this from SM. So probably I have to use SM. Okay, so here what we did was that we just import this test separately from scipy.stats, import this, so you can now use it directly as a function. Now what it is telling you, what is the p-value?
8.57.
8.57.
Except the null hypothesis. Except the null hypothesis.
Wrong. 8.57 to the power minus 21. To the power minus 21. That means 0.000000000.
Alternate hypothesis is true.
Alternate is true because this value is less than 5%, very, very less than 5%. So this is the chance of making an error about my claim of the population. So this is almost zero. So therefore, alternate is true, and I can claim that the average logins in 6 months is very, very different from the average logins in 4 weeks, which is understandable because how much am I going to log myself in 4 weeks? Maybe 4 times. In 6 months, I'm going to log myself in lots of times. Okay, because if I'm a regular customer, if I'm not a regular customer, then there's no difference. So if you see the data, in the data, it's not about the regular customers. There are some regular customers. There are people who have not logged in even in 6 months or 4 weeks. So overall, it is telling you that there is a significant difference, and it should give this result. In fact, otherwise it would be something really strange. What do you expect for this? What do you expect for the sales?
Same, the p-value will be small, and we can neglect the null hypothesis.
Yeah, p-value is very small because of the fact that here we are only talking about 4 weeks and here we're talking about 6 months. So हम कह सकते हैं यार तो लॉजिकल बात है यार, ये तो लॉजिकल बात है, ये कौन सी बात है, इसके लिए टी टेस्ट की क्या जरूरत है? तो the point is कि if you want to make a claim about the population, if you want to claim this to the business administration, then you need to conduct a statistical test. Otherwise, you cannot claim it without conducting a statistical test. The statistical test is going to give you confidence that this is actually true. Okay. So it turns out that my sales in 6 months is very much different from the sales in 4 weeks. That means that my sales is progressing on a monthly basis. 4 weeks is 1 month and 6 months is 6 months, right? So I am seeing a regular progression of sales from 1 month to 6 months. So that's that means that I am having a regular flow of customers who are coming to me regularly. So that's the conclusion I can make. Now about this ANOVA. ANOVA ka tarika jo one of the ways is this, I can use it like this. I need to have one numerical variable, so that is age. So I do the age with gender, I do age with area, age with mobile, and age with response. So first I do with age, although age is not really important, but here I'm trying out everything so that, just for your own knowledge that what happens. So these are the statistics that I want the system to display. So it will help me for each of these. You can make the null hypothesis and the alternate hypothesis. So let's see what's the answer here. So for the age and gender, I think the p-value is this one. So p-value is 94%. So what is your conclusion? Is the null true?
Accept the null.
क्या मतलब है null hypothesis? What does it mean? जी
Variation of mean in groups are equal.
नहीं, tell me with respect to age and gender that the p-value is more than 5%. It is 94%. What is your conclusion?
The age of male and female, mean age of male and female is almost same.
Yes, the mean age of male and female is almost the same. Exactly, that is the conclusion. That's good. And what about in this case? Age and area? 80%.
Again, we can say that
Null hypothesis is true.
Again, same thing. Age and mobile, again same. Age and response, again same. So it turns out that age is not different across any of our string variables. So that means that I can't distinguish between the gender, the area, the mobile usage of the customers, or the response of the customer, especially the response, because that is the variable of interest. So I cannot say that the people who have responded yes have more age than the people who responded no. I can't make any such statement. On the contrary, I have to make the statement now that there is no significant difference in the age of the respondents. Okay. I can't say that the response is depending on the age. The response has nothing to do with age. That is the conclusion that I have to make. Okay. The marketing response has nothing to do with age, which basically casts some credibility on the data, because the marketing, or maybe it is true because the marketing response is depending more on the salary situation rather than the age. And maybe the people that they took are all adult people who are salaried people, so the age has nothing to do with it. Okay. So these kind of conclusions, if you want to make a conclusion, then you have to do the statistical testing. Okay. Okay. Now for the
Sir.
G.
No. Sir, when
I can't hear you properly.
Sir, when I perform the EDA, sir, I basically categorize the age between 4 groups: the teenagers, the adult, the middle age, and the old ones. Sir, in my analysis, the middle age group are like the frequent buyer or customers of the website or the portal. So age is like very much important in the analysis. और यहाँ पे तो ये कुछ अलग ही बता रहा है सर, मेरे हिसाब से तो ऐसा नहीं है सर. आई यूज द हिस्टोग्राम बार ग्राफ्स, उसमें भी वो शो हो रहा था कि एज का सिग्निफिकेंट इम्पैक्ट है.
देखिए, when I check your paper, then only I can make a claim about this कि आपने क्या किया या नहीं किया. The point is कि if you look at this data like this, ये जो data आपके सामने, so let's make it like 25, right? Now this is the age, right? And we have the response variable, which is here. Okay, ये जो अब जैसे ये वाली बात है, we just consider this data, right? We are only making a claim कि I cannot distinguish on the average age. I'm not saying कि age, total age कितनी आ रही है, वो क्या आ रही है, age का तो खैर we are always going to take the average age, right? But the test is telling us that I cannot distinguish on the response based on the average age of the people who responded no or yes. Uski वजह ये है कि probably I will tell you the reason for that. Let's say the people who responded no and consider the people who responded yes. So let's say the range of people who responded no is their age is varying between, let's say, 35 to, let's say, 65. And let's say okay, the people responded their age is varying, like, let's say, minimum 30 to, let's say, 75. So you can see that there's an overlap here. As a, you cannot find out such a pattern that the people who responded no are all those people who are greater than 50 years old, and the people who responded yes are all those people who are less than 50 years old. There's no way we can have such a pattern. Even a teenager can say yes or no, even an old person can say yes or no, even an adult can say yes or no. So the statistical test is not able to distinguish making a significant claim about this based on that. That is the, मैं ये तो आपको बताना चाह रहा हूँ कि that is why you need to conduct a statistical test, because you cannot make a claim about the population unless the test approves it. If the test is telling me that there is no relationship between the age and the response variable, then I have to agree with that. I will not make the bar graph for that, because the you can आप एक काम कीजिएगा, you guys need to read upon this ANOVA thing more to get a better knowledge of this. But जितना एक data analyst को चाहिए होता है, I've told you okay, this is what you need to know, and this is the interpretation of the result. So I will personally not target the response variable based on the age. You can try to discover the difference. Visually there will be a difference, but statistically there is no difference, because the ANOVA test is finding out the variance of the age across the different groups. And if there is no difference in variance of the groups, then you cannot claim that the age is different across the groups. Okay, so you can show the pattern. It does not even mean कि वो आप pattern नहीं show करेंगे BI tool के ऊपर या किसी chart के ऊपर. आप, if you want, you can show the pattern. But if it was in my hands, I will not show the pattern. I will not show it, because according to my own understanding of the situation, there is absolutely no relationship. There is no difference in the average age. The people who are responding no and the people responding yes, there is no significant difference between their average behavior, average age. So if you are talking about the average age, then you will not show any chart. If you are talking about individual age groups, जो कि आपने खुद बना लिए, then you can do it. I will not do it. ठीक है? और ये तो खैर जब when I will see it, then inshallah I will verify it कि जो आपने claim किया है वो कितना सही है. अभी तो मैं उसको नहीं छेड़ूंगा. But I have my doubts. I'm sure that the results will agree with this. So now we come to this. ठीक है, Vinish, is this clear?
Yes, sir. Yes, sir.
So logins 4 weeks. Login 4 week is a very important. It could be a KPI, because login means that you are basically, doing what you are Logging in means that you are active. Okay. So I do that with respect to gender, area, mobile response, and now let's see what happens. So 61%, 13%, which is better, but it is not 10%, 69%, and oh wow. The login 4 weeks has only sigma relation with response. So what does this mean? Shabash. जी भाई बोलें यार, आप लोग बोलें.
Again, 4 weeks has different. It means that something is going on.
So there is a significant difference
So we
between
neglect
the number of logins in 1 month of those people who responded yes or no. अब आप you will plot this and determine के the people who are responding yes, what is their average login? Okay, and the people who are responding no, what is their average login? That is your assignment that you have to do. Oh. Yeah, so I do the 2-key test. For the 2-key test, it's going to tell me the difference. In fact, oh, there is a significant difference because in this case we have just 2 groups. So the average login for monthly logins is very high for those who responded yes and very low for those who responded no. That's great, man. So the people who are responding yes to a marketing campaign are those who are having a very high monthly login. So that's a good conclusion that we can make. Similarly, we do about the login 6 months. Logins, oh wow. Login 6 months, I have a significant relationship with gender because this is 3.5%. This is even 10%. So this is less than 10%. This is also acceptable to me. This is acceptable. This is not acceptable because it is 81%. And again, this one is acceptable. So, it means that login 6 months is gender के हिसाब से और area के हिसाब से. So our profile is building up very rapidly. What is the conclusion here? In both these, what is the conclusion?
for gender and data.
क्या कह रहे हैं?
There is a significant difference in gender-based login.
The gender is also varying. Males and females are different. Males and females are showing a different 6 monthly login behavior. The 6 monthly login behavior is also different for the area as well as for the response. So you need to put that in business terms. So I take the 2-key with respect to response and all these 3 and draw the graph. Oh, response the same and females are more than males. The females are logging in more 6 monthly on a basis than males, significantly more. In fact, I think I missed out on one thing. Gender. We also have to plot for this area, right? Area urban. So that's what you expect. Obviously, urban people are going to give you more response than the rural ones. So there is a significant difference. Now we are confident about this. There is a significant difference. Now we are very confident about this. That's what you need to keep in mind. And now we come to this real thing, sales 4 weeks. 72, 3.3, which is sales 4 weeks area. And O, response is very significant. So let's see for this. Urban is way more sales 4 weeks than this. And in the response, hey, what does this mean? For the no, it is almost insignificant as compared to this. So for the monthly sales, the people who are responding yes are really generating more monthly sales than the people who are responding no. For the login, the behavior was not that significant, so login seems to be associated with sales. क्या कह रहे हैं? Okay, for the sales 6 months, nothing, and this. So you can see that for the sales 6 months, sales 4 months, login 6 months, and login 4 months, all of these variables are correlated in one way with the response variable. So that's one very strong conclusion that we take away. We have nothing to do with the age with respect to the response variable. And the sales 6 months, sales 4 months, on a monthly basis, I am correlated with my area. And on the monthly login basis, on the 6 monthly login basis, I am correlated with my area and gender. Okay, so that's a pretty strange sort of, that's a pretty strange behavior. Can you try to understand this right now? देखिए जब हम monthly login की बात करते हैं, it is related with response, so that is understandable. Okay, okay, people who are logging in more, whether it is on a monthly basis or a 6 monthly basis, they are likely to respond yes more, significantly more likely to respond yes than no. That is understandable. But when we talk of the number of logins in the last 6 months, then I am also correlated with the gender. So I just have to keep that information, that this is what a data analyst does, right? I just have to keep this information in my mind, that the 6 monthly login behavior is different from males and females. It's not a very high difference, but there is a significant difference that females are logging in more in the last 6 months than males. But that behavior is not distinguishable on a monthly basis. And also the urban people are logging in more. People from the females. So females from the urban areas are logging in more. That's probably one conclusion. And for the sales 4 months, I have the area. I think I log in 4 months also, that was the area, right? I don't know about the login. Also, no, login 4 weeks. Login 4 weeks was just the response. But the sales 4 weeks is correlated with the area as well. And the sales 6 months is only correlated with the response. Yeah, so So let's talk about it. But what is your आपका क्या हिसाब किताब है? What do you think? Let's have a discussion on it right now for 5 minutes. Start discussing. जी जी भाई Daniel, what is your understanding of the situation?
Yeah. So what I think, based on what we were looking at right now, is कि जो है ना responses है ना उनका एक तो आपका login तो है there is a correlation between how much they logging in, as in we can see from the trend that females are more logging in. We can also start if we look more deeply, right? How much are they buying? Like what is the volume that they buy? हम ये भी देख सकते हैं साथ में वो monthly sales उनको कितनी sales की फॉर एग्जांपल यूजर बेस कितना बाय करता है अगर हम वो देखना शुरू कर दें तो हमें शायद एक और अंडरस्टैंडिंग बढ़ जाए
हाँ ठीक है गुलाम कमर, what is your understanding?
Can you hear me, please? Hello.
जी जी
Sir, sorry, here is some noise I am right now, and as per my understanding, we should we should reject the null hypothesis because it's far less than the 5%.
नहीं null hypothesis की मैं बात ही नहीं कर रहा, मैं तो कह रहा हूँ कि what is your understanding of the fact कि the response sales 6 months, sales 4 months, login 6 months, login 4 months is showing a significant difference across the response.
Yeah.
इसका क्या मतलब है? इसको आप बिजनेस टर्म में स्टेट कर सकते हैं इस रिजल्ट को?
Probably females are login more frequent than the men, and who are login has an impact more than who is not logging.
Login has an impact.
I mean, who is login actually has impact, has significant impact, because people who are mostly are females, and females are more than male, and they are trying to log in, and because of the login, there is an impact. Right? Yes.
Yeah. So in the business term, it is good for the business to know that the people who are logging in more, whether it is on a monthly basis or on a 6 monthly basis, or people who are generating more sales, whether it is on a monthly basis or a 6 monthly basis. Now we are extremely confident that these are the people who are going to give you a yes response. देखें, एक तो ये बात होती है कि the business has some idea about the situation, right? The business can say, यार जो सेल लेके आ रहा है उसको टारगेट करो,
But now we are confirming that through statistics, right? And maybe the business does not know about the logins, but now we are confirmed about the logins as well. It's not necessary that people who are logging in are also generating sales, but they have a tendency to say yes to your marketing campaign. Do you understand? If I'm logging into a portal, it's not necessary that I'm always generating sales. So these are the information that you need to derive from your data and put in your business. You need to think in that way, okay? Okay, so now we have these facilitation from, everything is clear right now regarding this?
Yes, sir.
Okay, so इसका exercise आपको मिलेगा बहरहाल. So we have this.
Sir, can you please repeat this concept?
Yeah, I cannot because I'm tired.
Sorry.
Again, I will just write it down so that it will be more clear. Okay. The people or customers who are generating more sales on a monthly or 6 monthly basis, or people by customers who are logging in more on a monthly or 6 monthly basis, are more likely to respond yes to my marketing campaign. That's the main conclusion that because you primarily you need to understand the response variable, but there are also some other information जो कि हमने ऊपर निकाली. You should be able to document that in this way. Okay, is this thing clear?
Okay, sir. Thank you.
Okay, so now I have this cross tab, and cross tab is a very very useful function. I can do a cross tab between response and gender. And then I conduct this because I told you that there's a test which is done between two string variables. So let me just do this. So this is the contingency table. So let me just make it in a good way like this. I think the table is not printed properly. So it's more like this, you can say. So yeah, so now it's much better. So females who responded no are 306, and those who responded yes are 152. Males who responded no are 250, and those who responded yes are 292. Now you can see another discrepancy because we saw that females are more likely to respond. So we don't know how many females and males are there in total in the data. So I think there are more females. So I have around 450 females, and I have more than 500 males. But the females are still more likely to respond than men. Okay. So in this case, what is the purpose of this? Can you determine the null hypothesis in this case? There are no numbers here, right? I have two string variables. One is the gender, the other is the response. So what could be the null hypothesis here? Can anyone tell me?
The average mean of male and female responses will be remain same for both no and yes.
Average what? Average what? Sorry. Average is nothing. Average age kuch bhi nahi hai. I just have two string variables. जी भाई. The null hypothesis can be that there is no difference in the response based on the gender. Alternate hypothesis, there is a difference in the response based on the gender. The response can vary based on the gender. That's it. We already know from above that the females are likely to respond. Females are likely to respond yes. No, that was not the conclusion. What was the chart there? Yeah, I just sorry. Let me just clear this. There was one chart. Yeah, this one. So this was with respect to login 6 months. ठीक है, यहाँ हमें क्या पता चला कि females are more likely to log in the last 6 months than males. But we also know that login 6 months is related to response. So we made an indirect conclusion if females are more likely to respond yes than males. But we can't make a conclusion unless we do the chi-square test. So for the chi-square test, this one we did. So the significance p-value is almost 0, so we reject the null hypothesis. So what we say is that the null hypothesis is rejected. That means the response is differing based on the gender. So I don't know if females are more likely to respond. My conclusion is that females are more likely to respond because 300, if you see the ratio here, I don't know how to determine the ratio. Can you make a conclusion? So 53% males are responding yes, and 33% females are responding yes. So that means that males have a more tendency to respond yes. And now we can make that conclusion because the chi-square test is telling us that there is a difference between the gender and response. So response is different based on the gender type. So that means that males are responding more, not females. Okay. Similarly, I can make a cross tab between response and area. Again, I have to reject the null hypothesis. And again, urban there's a more chance, so now it is confirmed between response and email. So it seems that the premium ones have a more tendency to respond yes than the free ones between response and mobile. So it seems here that the people who are responding yes, they almost always had a mobile. Okay. So we'll just take a small break for Isha prayer and then we'll be back. Okay. Just to keep on reflecting on this and we'll be back after a short break. Yeah, so we have seen today 3 types of tests, t-test, ANOVA test, and the chi-square test. I have given you the code to use these 3 tests. These 3 tests are going to be used very frequently in your exploratory data analysis. And you should be able to use them. You should be able to use them in the future assignments जो कि मैं आपको दूंगा starting from today. Okay. So besides this is some, you just these are some histogram plots. I just renamed some columns in the so age histogram. So what is the interpretation for this? Who is going to tell me? So if you have with a normal अजीब सा histogram है, what do you think?
So it is rightly skewed.
No, I don't think so. There is a skew.
I don't think so. There is a skew. It just does not have a normal shape, right? The normal shape is supposed to be something like that. This is not a skew. This, you can't call this a skew. It's a very strange distribution. Yeah, iska, you should plot the density curve to understand it in a better way. The normal curve is going to be like this. It's very strange. So the conclusion is that the values are not actually normal, but you can't even say that they are not normal. So you have to categorize it as a normal distribution. The probability or yeah. I think the conclusion you can make. Sorry?
So it's just a frequency table. It's just telling us how much people are contained in a particular range of age.
I mean, when we draw the normal curve, I approximate the normal curve from the histogram, right? I'm just making an approximation. So the age values seem equiprobable. Because you see, they're almost the same. I mean, obviously, this portion of customers is supposed to be less than this portion of customers, so it is supposed to taper down. But in this area, you can say that the probability is almost is equal, because normal distribution is a curve of the probability, right? So the probability is almost the same. So this is what I was telling you कि जब बीनिश ने जो बात की कि एज के हिसाब से मुझे डिफरेंस नजर आया है. So the normal curve will tell you कि, I mean, this is like a plateau, right? कि the frequency is almost the same. The probability of these values is almost the same. So we might not be able to distinguish based on the age as far as the response is concerned, because the values are equiprobable across both the yes and no values.
Sir, जो आप कह रहे थे तो हमारा curve theta नहीं आ रहा है, क्योंकि I think उससे नहीं आ रहा. We starting at from 20, age 20. Had this been from 0 to 90, वो इससे dip भी आ जाता.
Yeah, but in the case, you are right. So 90 age is not an outlier. So मैं कहता कि इसको हम skew नहीं कह सकते.
बिल्कुल नहीं कह सकते, क्योंकि अगर हमारा 0 से प्लॉट शुरू होता ना कि एज हमने टीनेज में उठा लिए होते हैं 0 एज 1 2 3 4 5 20, तो हमारा दूसरी साइड पर डिप नजर आ जाता है.
हाँ, ये भी हो सकता है. Because I mean, that's what I'm saying कि it's the data is recorded in such a way कि the normal curve is like that. इसका आप लोग डिस्क प्लॉट बना के देखिएगा, एसएनएस का जो ना सीबॉर्न का जो डिस्क प्लॉट है, जस्ट प्लॉट दैट एंड सी हाउ इट लुक्स. Log in 4 weeks is because I think we have so many zero values, so that's why this is not even a skew. So this is the outlier value which we have. So we need to probably आप इसको clean करके देखें. Try to clean this. Try to remove the zeros, but there are so many rows with zeros, so it's like a normal curve in any ways. Similarly, this is log in 6 weeks. Again, this is the outlier because of the zero values. There are so many zero values. Other than that, this does seem like a skew. If I remove this zero, so it does seem like a very strong skew, because some people are logging in 35 times, so they are creating a huge skew. इन सब के normal curves बना के देखें आप और इसकी interpretation करें. Oh wow, this is a large skew. Similarly for this, so there is a skew, but I think it's because of sales zero. So many people have logged in, but they have not generated any sales. ठीक है. अच्छा, Anderson test is a test of normality. So sales 6 months. Let me just gather my thought. The Anderson test actually records at different significance level, 15%, 10%, 5%, 2.5%, 1%. And in each case, it's less than the critical value. So it says the data does not look normal, and I agree with this because this is not a normal distribution, primarily because of these zero values. So we have to do something about that if you want to use this data, especially in machine learning. Similarly, ditto for that. And QQ plot, if I take the QQ plot for sales 4 weeks, you can see the QQ plot for sale 4 weeks is not lying on this straight line, which is the red line. So that means it is not normal. And similarly for sales 6 months is not normal. So sample quantiles versus theoretical quantiles. So this just to check the normality QQ plot. So I think we need to do something about these data. What should we do? क्या करना चाहिए?
So analyze the box plot and then remove the outliers.
Have you guys done that? Have you guys done that?
No, sir.
No, sir.
तो आपने मिड टर्म में बॉक्स प्लॉट नहीं बनाए लॉगिन वगैरह के?
बनाए हैं एक।
मैं तो बताए ना, ये तो मैं पूछ रहा हूँ।
सर बॉक्स प्लॉट बनाया मतलब बहुत एबनॉर्मल सर।
वही तो मैं यही तो एबनॉर्मलिटी, दिस इज व्हाट इट इज टेलिंग यू के द एंडरसन
विजिबल है।
हाँ, एंडरसन टेस्ट कह रहा है आपका डेटा नॉर्मल नहीं है। एंडरसन टेस्ट इज वन ऑफ द मोर रिलायबल टेस्ट, द अदर इज द शेपायरो टेस्ट। अच्छा चलें, लेट्स लुक एट दिस। सो दिस इज द सेल्स फाइल, ये मैंने अभी अपलोड नहीं की है प्रॉब्ली। So let me read this. So these are all the columns which are there. It's already casted to this format. I have 2 dates. So what am I doing here? I'm just generating data from a normal distribution, okay? And when I draw it, obviously, so it's going to be a normal curve. And a QQ plot is definitely going to be, you see, I basically generated the data from a normal distribution. So obviously the histogram is going to resemble a normal distribution and the QQ plot is going to be like this. The Shapiro Wilkinson test is one other test beside the Anderson test, and it is giving you a p-value of 47% on the data. So the null hypothesis is that the data is normal. So as the p-value is around 50%, so the null hypothesis is true, which means that the data is normal. And the alternate is that the data is not normal, okay? Similarly, the other test is the normal test, which is, I think, I don't know why we call it the K2 test. In this case also the same thing, null hypothesis is the data is normal. So again, it is telling the same thing. And the Kolmogorov-Smirnov test, I think this is the Kolmogorov test and this is the Anderson test, which we already did. Data looks normal, looks normal, looks normal, looks normal. So in this case, it is everything, because obviously I've generated it from the normal distribution. So if I plot the histogram of sales, so sales is very bad. QQ plot should be horrible as well. It's not lying on the straight line. So the Shapiro test is saying it's not normal because the p-value is 0, and the normal test is again p-value 0, so it's saying not normal. And the Anderson test should tell you the same, does not look normal, okay? So the point is that using all these tests and box plot and normal distribution plots, you can decide whether your data is normal or not. and then you have to convert that to something which is normal, so that you can work with that in machine learning. Unless your data is normal, you can't put this data in my machine learning algorithm. So in the case of, I think I will give you that as an assignment, that you clean the data so that everything becomes normal, this sales data and this. So what will you do? Okay. We have this other file as well, the statistics. Let me just clear the outputs. So let me import this sales file. It's the same file. The types are already there. We have 8,400 rows. These are some of the header files. So ANOVA test, sales with order priority, shipping mode, region. So this is the ANOVA test. So let's conduct this. So nothing here. Yeah, so sales is varying across the 2 shipping modes. Okay. So we have to find the 2 key for that, uska varying kiske hisab se ho raha hai. Sales is not varying across regions. Sales is varying across, which is understandable because the shipping mode, if it is going by aeroplane, it is fetching you more sales probably because someone has bought something really expensive, so you want it to deliver quickly, something like that. Across the province also, sales is not varying that much. Across the customer segment, nothing. Across the product category, so there's a lot of difference across the product category. So you need to put the 2 key there. Product subcategory also has a lot of difference. And what about the product container? Again, there's a difference. So the sales, the mean sales is different across different product containers, different subcategories, different categories of product, and the shipping mode. Okay, so you need to put the 2 key test. So let's do the 2 key test. Yeah, so the shipping mode, now you can see where the difference lies actually. I have what are the shipping modes I have here? Yeah, so I have these 2: delivery truck and express air, delivery truck and regular air, express air and regular air. So reject the null hypothesis in these 2 cases. You see, reject means the reject the null hypothesis in these 2. So there's a significant difference of sales between the delivery truck and the air, so which is understandable. So sales for the truck deliveries and sales for the air deliveries are significantly different from each other, which is understandable. Okay. In this case, furniture, office supplies, and office supplies and technology. So sales for these 2 and sales for these 2 are significantly different from each other. For the product subcategory, oh wow, there are so many subcategories. Appliances, bookcases, appliances, chairs, appliances, computer peripherals, all of these are true. So there are so many truths here. So you have to, I think, put some filter there in order to discover. So false means there is, for example, there is no difference between the sales of storage organization and telephone and communication material, or between, let's say, rubber bands and scissors, rulers and trimmers. So all of these are very minute type of data which are of interest to product managers or the sales managers. Okay. Similarly, the product sales versus product containers. Oh, so all of these are true. Jumbo box and medium box, small pack, jumbo box and wrap bags. All of these are understandable. And now we conduct the chi-square test. Okay, who is going to tell me the alternate and null for this? Shabash. Ji. Who is going to make a try? Binish. Haris Bilal.
Sir, mean of customer segment is equal to mean of product category.
What?
Sir, mean of customer segment is equal to mean of product category is the null hypothesis.
नहीं नहीं, यहाँ पे मीन कहाँ से आ गया? This is a chi-square test. There is no numerical variable. Where is the mean? Mean of what? Customer segment is a string variable. Product category is also a string variable. There is a numerical variable? You talk about the number. So we can say ke, the customer segment is different. The null hypothesis is that the customer segment is the same across different product categories. And the alternate hypothesis is that the customer segment is different across different product categories. That's what you say. There is no mean here. There is no numerical variable. You see, product categories are furniture, office supplies, and technology. Customer segment are consumer, corporate, and home office and small business. So what was my claim? That the customer segment is the same across the product categories. That's the null hypothesis. कि मैं कहूँ कि जी corporate वालों ने ही सिर्फ ये तीनों चीजें खरीदी हैं. That's the null hypothesis. But the alternate hypothesis is that कि home office वालों ने एक furniture खरीदा है, small business वालों ने कुछ और खरीदा है. That thing. So if I conduct this test, so let's see what's the answer for that. So fail to reject the null hypothesis. So there is no significant difference. I can't say that the customer segment is varying across the product categories. Okay, if these four segments have bought furniture, then they have also bought office supplies, and they have also bought technology. So we can't detect any difference based on the customer segment across the sales of product categories. That's the conclusion that you need to make. Similarly, about product container and product category. So यहाँ पे हमारा alternate hypothesis क्या है कि in different types of containers we are shifting different types of categories. So what's the conclusion? Yes, that is true. Because the furniture is a large item, so it will go in jumbo box and jumbo drum, something like that. Office supplies will go in small pack, and so you can see the difference between that. So you must be able to detect when to use a chi-square test, when to use a t-test, and when to use an ANOVA test. Otherwise, you have not learned it. Okay, sales DF. Yeah, so all of these are numerical columns, but that is a stupid thing to do, to find out the t-test between all the numerical columns. That is not what we want. We just want to, yeah, between sales and profit, I'm not able to detect anything regarding a t-test. It does not make sense. I can make a scatter plot to determine that. Okay. So I think that finishes up the lecture for today. So we have done the hypothesis testing in detail. We have taken 3 tests. We have taken lots of examples. I will upload these 3 things today to your drive. And you will have to do an assignment. Obviously, I will upload another data set. And then you will have to do an assignment based on t-test and all those things, and you have to make conclusions. Whatever you can, you should do it. Okay. So are there any questions?
Sir, अगर इसको further हमें समझना हो, सारे हम टेस्ट हम देखें, कोई आप recommend करेंगे कोई book या कुछ further understand the test कर किस तरह, like the methodology behind it or the method behind each test?
देखें, from the perspective of data science, I do not think so that you will need more statistical tests.
नहीं मैं इन्हीं टेस्ट की बात कर रहा हूँ. For example, हमने t-test देख रहे थे, हम सब चीजें देख रहे थे ना.
हाँ, तो you can You want to know more examples?
No. I want to know more about the test itself. कि वो उसकी why it works the way it works. वाला चीज़ ना उसकी behind the
Okay,
scenes.
so I think the best thing is YouTube. Because YouTube के ऊपर they can explain you t-test in 1 minute or 3 minutes or 5 minutes. So you can watch multiple videos. एक वीडियो से आपको सही तरह सारी चीजें समझ में नहीं आएंगी. Watch at least 2 videos on t-test and ANOVA and chi-square test, and then you will be able to understand better. Okay.
मतलब किताब अगर हो रहा तो वो आता पढ़ने में जो फर्क आता है।
किताब Okay, I will search for some book and tell you inshallah ताला. Just इसको ग्रुप पे डाल दें आप क्वेरी को, व्हाट्सएप ग्रुप पे डाल दें, ठीक है, ताकि मुझे याद रहे फिर. Okay, so I'll give you a data set which will be complicated. So जो उसमें आपने cleaning करनी हो वो कर लीजिएगा, and then you just conduct these tests, normality test, t-test, if it is applicable. You have to make a justification, the ANOVA test and the chi-square test. And then make interpretations, make conclusions, write down everything in the notebook. Okay?
Okay, sir.
Okay, so I'll be uploading a lecture soon. Please listen to it because I am sure that you need to understand the concept, because if you do not interact in the class, then that means the learning is not that much. Even now, some students have left the class. So if you are not learning, then nothing. There's no need of taking the diploma if you're not learning, because then you don't develop the skill if you don't do hands-on and you don't attend the class. So you need to learn. Okay. So I'll just upload the lecture inshallah in just half an hour or something like that.
Thank you.
ठीक है, सही है. Okay, अस्सलाम वालेकुम.